Good evening, friends. Let us continue with our time and work related problems. A, B, and C can do a work in 6, 8, and 12 days respectively. Doing that work together, they can get an amount of 1350. What is the share of B in that amount? They can do in 6 days, 8 days, and 12 days, right? So, what would be the share on each day? 1 by 6, 1 by 8, and 1 by 12. They'll be able to do on each day, right? 1 by 6, 1 by 8, and 1 by 12. What is 6, 8, and 12? The LCM is 24. So 4 is to 3 is to 2. Right? 4 by 24 is to 3 by 24 is to 2 by 24. That is the share. We should not take we should not take 6 is to 8 is to 24, right? 8 is to 12. No, this is wrong. We should take what is their capacity. 6 is to 8 is to 24 is not their capacity. Their capacity is 1 by 6. 81 by 6 is to 1 by 8 is to 1 by 12. This is the daily capacity. If you take 6 is to 8 is to 12, okay, uh, this 12 guy will get the maximum share, right? The 12 guy who is the slowest. He is the slowest, right? He is the slowest. He is the 6 guy is the fastest. 12 guy is half as fast as the 6 guy, which is A, right? We should not give the slowest guy the highest amount, right? So this is wrong. 6 is to 8 is to 12 is wrong. In fact, we should be doing 1 by 6 is to 1 by 8 is to 1 by 12. That is the correct way. Now 4 is to 3 is to 2 is the ratio because denominator 24 is same for everyone. Now what is base share? 3 by 4 plus 3 plus 2. What is 3 by 4 plus 7 plus 2? 9 into total amount 1350. Right? 9 15s. 135. Right? 3 into 150 is 450. So 450 is the correct answer. Next one. If 6 men working 8 hours a day, then 1680 per week. How much will 9 men working 6 hours a day and per week? So per week in both cases are common, so we can ignore. 6 men working 8 hours in a day. 8 hours in a day. So what is the total work that they have done? 6 into 8. Right? 6 into 8 they had worked and they had got 1680. 6 into 8 they had worked and they had got 1680. That means each hour, what is the pay? 1680 by 6 into 8. Simple, right? 6 each hour per each man hour. What is the pay? 1680 by 6 into 8. Now 9 men, they work for 6 hours each. That means 9 into 6 is the total number of hours. Total number of hours, what is the pay that should get? For each hour, this is the one. For 9 into 6 hours, that 54 hours, this 9 into 6 into this one. Simple, right? 9 into 6 into 1680 by 1680 by 6 into 8. This is very simple calculation again. 6 gets cancelled. This goes 210 times 9 into 210 is 1890. Right? This is also a simple problem. Next. 8 men working 9 hours per day can build a wall 18 meters long, 2 meters wide, and 12 meters high in 10 days. Okay, 8 men are working. They are working for 9 hours a day and they are working for 10 days. Right. Right. So, what is the total number of hours? That is, total number of the hours would be 8 into 9 into 10. Right. 8 into 9 it is the total number of hours. Total number of 9, 8 into 9 into 10. This is what that they are working. Now they are working like this. Now what is the output that they have got? The output is they constructed this 18 meter into 2 meter into 12 meter. 12 meter wall. So what is the volume? This is the volume, right? 18 into 12 into 12 meters. This is the wall that they have constructed. 8 into 9 into 10 watts hours they worked and they constructed 18 into 2 into 12. So for example, they work for 8 x hours and they made, let's say, 10 objects. Simple like this. It's a direct relation. If they work for y hours, they work for 2 hours, 2x hours, they'll make 20 objects. Simple, right? They work for more hours, they will make more. So this is more, they'll make more objects. Right? They work for 8 into 9 into 10 hours, whatever is, let's call it x, then 18 into 2 into 12. That is the volume of the wall that they have created. Now what is saying, 32 meter, again another one, 32 meter, 3 meters wide, 9 meters high. This is the second object that we have to create. Okay, 32 into 32 into 3 into 9 is what we have to create. Right, by working 6 days, 6 hours and 8 days. 6 hours and 8 days, and how many people? We don't know. Right? Uh, how many people? We don't know. Right? Right? So now, for this is directly proportional. So by working 8 into 9 into 9 into 10 hours, we are able to create this much. To create this much, to create this much, what is that needed? To create this much, this was needed. To create this much, how much was needed? So this into, right, to create this much, this was needed. Right, 8 into 9 into 10, 8 into 9 into 10 is giving 18 into 2 into 12. Right. So 32 into 3 into 9. For this, how much is needed? So this into this by this. Right. 32 into 3 into 9 into 8 into 9 into 10 by 18 into 2 into 12. This is the total number of hours that is needed. Right. This is the total number of hours. Same thing. Same thing. 32 into 3 into 9 into 8 into 9 into 10 by 18 into 2 into 12. Right. This is the total number of hours that is needed. Now he is saying these guys are working for 6 hours and for 8 days. Okay, by 6 hours, by 8 days, this will give the number of men that are working. Right? You just cancel all of this. Simply, these are all simple calculations only. Once you cancel all of this, we are getting 30 days. Right? You can do this calculation now. Right. Let's get to the next one. If 5 engines consume 6 tons of coal when each runs 9 hours per day. How much coal will be needed for 8 engines, each running 10 hours per day? Being given that 3 engines of the former type consume as much as 4 engines of the latter type. 3 engines of former consume as much as 4 engines of the latter type. Okay. What we will do? First, let's assume X and Y tons are consumed per hour from both the types of machines. Okay. First one is consuming X. Second one is consuming Y. Okay, per hour. Okay, per hour it is consuming. Now what is it saying? 3 engines consuming. Each engine is consuming X, 3 engines will consume 3X. Okay, and 4 engines of the latter type. Right, is equal to 4Y. Simply, right? 3X equal to 4Y. That's what we had written. 3 engines, whatever that they are consumed, is equal to 4 engines of type 2. Okay. Now what you are saying in the first type. 5 engines, they are consuming 6 tons when they run 9 hours. We assume that X is in per hour, what is the consumption? It has run for 5 engines into 9 hours. 5 into 9 into X, this is equal to 6. This is the first equation. Okay. Then what is saying? Second, 8 engines running for 10 hours. How much the consumption would be? 8 engines running for 10 hours, and we assume Y. Y is the consumption for second one. What is it? 8 into 10 into Y is what? Y is equal to 3 by 4x. 8 into 10 into 3 by 4x is what? This is the problem that we have to solve. Right. Now solving this. Take the first equation. 5 into 9 into x equal to 6. X equal to 6 by 5 by 9. Same, just let's substitute here. 8 into 10 into 3 by 4x. In place of x, we will call it 6 into 5 by 5 by 9. Right? When you cancel this goes 2 times. This also goes 2 times. This was 2 tons. 2 into 2 into 2. It is 8 tons. Right? So that is the answer. 8 tons. The problem is very simple, right? 5 engines. 5 engines consume 6 tons and they run at 9 hours. Let's assume X tons get consumed every 1 hour by 1 engine. 5 into 9 into they run for 45 hours. Every hour X is equal to 6. 45 into X equal to 6. Similarly, we assumed Y for second machine. 8 hours, 8 engines, 10 hours into Y is how much, that is a question. It is also given that 3 engines of the former type consume as much as 4 engines of the latter type. We assumed X is per hour. So 3 into X per hour, right, of the former engine. 3 times of X is equal to 4 times of Y. We just did the substitution and then we have achieved this answer to be 8 tons. So it is also an easy problem only. Now let's get to the next problem. A garrison of 1,000 men is provisioned for 80 days. After 30 days, the garrison is reinforced by 1,000 more men. How long will the remaining provisions last? What is a garrison? Garrison is the group of soldiers living in a town or a port for its defense, to defend that place. That is called garrison. Right. Soldiers are kept at a lot of places, right? You see a lot of border force soldiers, etc., etc. These are all called garrisons. Okay. Now, a garrison, this group of soldiers, 1,000 men for 80 days. Let's say there are all food packets. For 1,000 men for 80 days. Let's say total food packets are there. What is this? For 1,000 men and 80 days, 1,000 into 80 worth of food packets. That is 80,000 worth of food packets. Okay, 80,000 food packets are there, let's say. Okay. Now, after 30 days, in 30 days, they would have eaten 30 into 1,000. 30,000 would have been finished. So, of this 80,000, 50,000 packets are left now. Okay. Now, 1,000 more got added. So, that means total of 2,000. 2,000 people are there and 50,000 food packets are still there. That means this will be 25 days. Right. 2,000 people, 50,000 food packets. That means they will be sufficient for 25 days. This is also a very easy problem. In all these problems, the most important thing is to understand it clearly and be able to write correct equations. You should not get confused. You should think clearly and be able to write correct equations. Okay. You do a lot of practice, then you'll be able to do all of this. 40 men can paint 60 walls in 8 hours. Okay. What is the total work? Total work is 60 walls. And total job is 60 walls. And how much they have worked? 40 men into 8. 40 into 8. It has given 500 man hours, work hours to paint 60 walls. Okay. It took 500 to paint 60 walls. If 8 men leave the job, how many walls will be painted in 12 hours? Okay. 500 hours. In 500 hours, they painted 60 walls. In each hour, sorry, it is not 500, 40 into, it is 320, 40 into 8, 320, right? In 320 hours, 40 into 8, 320 hours, they have painted 60 walls. That means in each hour, they are able to paint 60 by 320 by one man, right? That this is what that is given. 40 men have painted 60 walls in 8 hours. So 40 into 8 is the amount of time that they have spent and they have finished 60 walls. So 40 into 8, 320, 60 walls. Each hour they have finished 60 by 320 walls. Okay. Now what they are saying, if 8 men leave the job, how many walls will be? 8 men leave 8 men leave the job. There's a grammar mistake here. It is not leaves. It is leave. 8 men leave the job. How many walls will get painted? Okay, there will be only 32 men. 32 men in 12 hours. So what are the number of hours? 32 to 12. Each hour, how many are getting painted? 60 by 320. 30 into 2, 32 into 12 into 60 by 320. 32, 32 cancel, 0, 0 cancel, 6, 12, 72 is the answer. Right? This is also very easy problem. We just need to understand in 1 hour how many walls are getting painted. This is the trick here. You need to be able to calculate this. In 1 hour, how many walls are getting painted. Now let's take another example. A group of 20 cows can graze a field in 3 acres in size in 10 days. 3 acres. Okay, what is the total work? Total work is 3 acres. And how much time they have taken? 20 into 10 days. So 200 days. Okay, in 200 days, they have finished 3 acres. Let's assume X is the number of acres. One cow can finish grazing in 1 day. Okay, so now there are 200 days. 200 into X. X equal to 3. X equal to 3 by 200. X is what? Number of acres a cow can graze in 1 day. How many cows can graze a field twice as large in 8 days? What is the job now? Job is twice as big. It's not 3 acres, it is 6 acres. Now, how many cows are needed? Let's say that variable is C. How many cows are needed? How many C's are needed when they graze 8 her 8 days? C into 8, these many cow days are there, these many days, C into 8 into daily 3 by 200. Daily 3 by 200 that we had calculated already. Okay, C into 8 into 3 by 200 is equal to 6. This means 6 into 200 by 8 into 3. 3 goes 2 times, 8 goes 50 times. It goes 25 times, 8 25s are 200. 2 into 25 is 50. Right? So 50 cows are needed to finish grazing that. Okay? This is also a very easy problem. Now let's get to some pipe problems. Pipe problems are also very easy. Yes. Let's get to some pipe problems. A pipe can fill a cistern in 6 hours. Okay? Due to a leak in its bottom, it is filled in 7 hours. That means something is filling and something is leaking. Okay, something is filling, something is leaking. Something is there is this capacity and there is this capacity. So in 6 hours, a pipe is being filled. A pipe is filling in 6 hours. That means each 1 hour it will finish 1/6 of the system, right? Each 1 hour. In each hour, it will fill 1/6 of the system because 6 hours it is taking. Now there is a leak in bottom. Let's assume this leak will take y hours to finish it, to empty it. Okay, that means each hour 1 by y is getting drained out, right? 1 by y is getting drained out. Let's say in y hours it will drain everything. That means each hour 1 by y will get drained out. What is saying? It is filled in 7 days. So that means 7 days of 7. It is filled in 7 hours. What that means? 7 hours of filling and 7 hours of emptying. Right? 7 into 1 by 6. 1 by 6 is per each hour. 1 by 6 is getting filled. 7 into 1 by 6 is getting filled. Minus 7 into 1 by y is getting drained. So all filling minus draining should be equal to complete system. Our complete system means complete one. Right, 7 into 1 by 6 minus 7 into 1 by y equal to 1. 7 by 6 minus 7 by y equal to 1. 7 by 6, we're getting this one this side. 7 by 6 minus 1 equal to 7 by 5. 7 by y. So that means 1 by 6 equal to 7 by y. Y equal to 42 hours. Okay. That means left alone, this leak will finish emptying this cistern in 42 hours, whereas this one is filling in 6 hours. Okay, that's why we are able, both of them, even though both are open together, they were able to finish it in 7 hours. Okay, this is also another easy problem. Now, 3 pipes A, B, and C can fill a cistern in 6 hours. A, B, C to put together, they are finishing it in 6 hours. After working together for 2 hours, C is closed and A and B fill the remaining. A and B filled the system. So A and B filled the remaining system in 8 hours, and find the time in which the system can be filled by pipes. Okay, three pipes A, B, and C can fill a system. Okay, in 6 hours. That means in 2 hours, how much would have got finished? 6 hours is total. 2 hours means one third would have been finished and two third would have been empty. Right, in 2 hours. Now this C is stopped at this point. A and B they took 8 hours. They took 8 hours to finish this 2 by third. Okay. How if they have to finish the entire one, how long does it take? This is simple. 8 into right. 8 into 1 by 2 by 3. 8 into that equals 8 into 3 by 2. Right. If they if it is two third, then they will be able to finish in 8 hours. If it is to be complete system, complete tank, then they will have to finish in 8 into 3 by 2 hours, which is equal to 12 hours. Right. 12 hours A and B will take to finish it. A and B together. Now, what total they are taking in 6 hours. So you can directly write it here. 12 hours A and B and C something we don't know. And together they are making 6 hours. That means C is also equal to A and B together, right? Simply. I am able to do in 4 hours. You are able to do in 4 hours. That means together we will be able to do in 2 hours. Right? Simply. You don't need to do the other calculation. So 12 hours, then total is 6 hours. That means C is also doing 12 hours. Okay. This is one way. But every time the numbers will not be so easy. So we should know the original path also. How exactly we should solve this. So 6 hours of A plus B plus C is equal to 1. 6 into that each hour 1 by A by each hour 1 by B by each hour 1 by C. Now 1 by A plus 1 by B is taking 12 hours. That we know. 6 into 1 by 12 plus 1 by C is equal to 1. That means 1 by 2 plus 6 by C equal to 1. Right? Then 6 by C equal to 1 by 2. That means C equal to 12 hours. Right? Now A and B, you should not get confused. 1 by A plus 1 by B is equal to 1 by 12. Because irrespective of the A, let's even replace two different pipes with a big pipe. And that big pipe is equal to 12 hours. So 1 by A plus 1 by B is equal to 12 hours. You should understand this. Don't get confused. Even if there are two pipes, one pipe, it doesn't matter. Okay. Even if these two are replaced with one pipe which will fill it in 1 by 12 hours, which will fill it in for us, that is also good enough for us, right? So this problem is also very easy. 6 into 1 by 12 plus 1 by C. Okay, A, B, C are filling it in 12 hours. Sorry, in 6 hours. That means in 2 hours, one third would have been filled and two third is empty. And A and B are together taking 8 hours for this two third. That means for the complete tank system, they would have taken 8 into 3 by 2, which is 12 hours. Right. A and B together are anyway taking 12 hours. 6 into 1 by 12 plus 6 into 1 by C is equal to 1. Okay. This problem is also an easy problem. Now, let's take another problem. Pipe A can fill a tank in 10 hours. While pipe B alone can fill it in 20 hours. Pipe A can fill alone in 10 hours. B alone can fill it in 20 hours. C can empty the tank in 10 hours, 40 hours. Okay, all of them are open together. How much time it will take to make the tank full? Okay, let's assume X hours are needed to fill this complete tank. And within X hours, 10 hours takes for A, right? What that means, each hour 1 by 10 will get filled. Let's take X hours, X into 1 by 10. Plus 20 hours are needed for B, so that means X into 1 by 20 is B's contribution. And 40 hours, in 40 hours, C will empty the tank. That means minus X into 1 by 40. Okay, C is removing it. So X into 1 by 40, that has to be subtracted. X into 1 by 10 plus X into 1 by 20 minus X into 1 by 40. X is the total number of hours. All of this put together should be equal to 1. Okay, X into 1 by 10 plus 1 by 1 plus 1 by 2 minus 1 by 4. Just we're taking 10 common. Then X by 10 into 4 is the LCM. 4 plus 2 minus 1, right? Equal to 1. 6 minus 1, 5. right? X by 10 into 5 by 4 equal to 1, right? Okay. X into x by 10 into 5 by 4 is equal to 1. And that means 5 cancels, 5 goes 2 times. X by 2 into 4 equal to 1. That means x into x equal to 8 hours. So when two pipes are filling, then that would be positive contribution 1 by 10 plus 1 by 20. X by 10 plus x by 20. Right, each hour 1 by 10th will get filled by A and each hour 1 by 20th will get filled by B. So x hours x into 1 by 10 plus x into 1 by 20. That is the contribution of A and B. Now C is emptying x into 1 by 40. Okay. So this problem is also an easy problem. These are all easy problems. The critical thing is in all these time and work related problems, you should know how to write the correct equation. Correct equation. This is the most important aspect of this. After that, solving is not so difficult. You should know what is the correct equation. Per hour or per hour or per person, what is the amount of work? What is the output? We have to make this assumption correctly. Per hour, per person, how much is this? Then how many hours are there? How many hours they are working? How many hours they are working? We just need to multiply this and arrive at what exactly is the answer. So we need to clearly identify, we need to be able to clearly identify what is the work, what are the work hours on one side and what is the output on another side. We should not get confused. They are creating three walls. That means that's an output. If they are working for 10 hours, that means that's an input. What is output? What is the input? That we have to be very clear. Okay? If they are consuming something, if they are if they are using 100 liters of petrol. So this is on this side. If they are working for 50 hours, this is on this side. So you should not mix both of this. What is the work hours, and what is the output? Okay? What is the output? You just need to simplify the problems like this. Any doubts? Please reach out to me. All the best. Please go through this in detail and practice it yourself and then look at the solutions. Please make a pause before you look into the solution. First practice yourself. And then if you are not getting, then look into the solution. Right? All the best, please. Thank you.